Uh, Firstly, thank you very much, sir, for the kind and elaborate introduction, personal introduction. Uh, Dr. Reddy and Dr. Verma and the senior colleagues of mine from DRDO and the students and ladies and gentlemen. This is indeed an opportunity for me to share some interesting new ideas being pursued in my cluster. But before I proceed further, I would like to thank the organizers and also even compliment them for the efforts. It's not very easy, to organize such a big event, and really a huge compliments to them. One small disclaimer before I start. Much of the ideas that I'll be discussing with you today are being developed, experimented in my laboratories in the cluster, Med and Cos and the CS cluster. And I don't claim any originality to them, but I am their spokesperson. You can say I am an integrator, of their ideas, and I present them for potential customers like you. Now, the title of the talk is Network-Centric Defense in the Age of Information Technology. When I was asked to prepare for a talk, I thought it should be really in the frontier area, looking ahead, instead of focusing on what we are actually currently doing, because what we are currently doing is productize and deliver something that our customers require immediately, urgently. But at the same time, we will also look ahead and see what new things we have to do, short term, middle term, and long term. So this idea that I'm going to explain to you today is perhaps a very long term idea, but you will, I hope, find it quite interesting. Now, so there is this notion called information age. Of course, we all agree that we live in the so-called information technology dominated age. Every day we connect to internet, we download, we see mails, we do our activities on the net. In fact, without net, many of us cannot conceive our lives today. Net with a lot of software and a lot of intelligence. But can we say the information age has arrived? There was an age, earlier called industrial age. So, what was the clear marker of the industrial age? And can we, in fact, learn something from there and then decide whether we are in the information age at all today? So, we will see, as the cartoon says, one guy says, the newspaper tells him that we are in the information age, the other guy doesn't know. At the end of the talk, I'm sure we'll figure out which age we are. So, this is going to be a rough overview of my talk. We'll start with some deciders for warfare, for winning. Ultimately, in DRDO, we try to develop systems immediately required and maybe required long term for enabling our armed forces to prevail against our adversaries. So, what are the deciders that we will have to see? There are new concepts. One of them is this network-centric defense or network-centric warfare. Now, this one has been around for the last, I would say, decade and more. It was originally coined by one colonel from the American military called Boyd. But then, it's such a complex thing, it's almost like the proverbial elephant that different people, in fact, interpret it differently. So, we will have to see whether we can come out with a new interpretation. And in the process of, in fact, trying to understand on our own terms what is this net-centric or network-centric defense or warfare, we may find that there are some very good models for, first of all, understanding the concept better and then even implementing it. That's what I would like you to understand. Now, let's see what are the deciders for winning, as told by some ancient scholars. So, there is this famous Sun Tzu, some of you might have heard about him. He is theoretized, a great book called Art of War. This is highly quoted in military seminars and defense seminars. According to him, there is a matrix, which is shown there. So there is this knowledge that is key to winning, but knowledge of what? Knowledge of yourself and knowledge of your adversary. Both are equally important. And here the knowledge actually should include information about enemy's assets as well as your assets, and his capabilities as well as your capabilities. But then this matrix is, very, very simple, very basic. It assumes either you have 100% knowledge or 50% knowledge or 0% knowledge, but there is a lot in between. And your own knowledge may not be total, your knowledge about the enemy may not be total. So this matrix obviously has to be expanded depending on the actual amount of knowledge about yourself and about your enemy you have. I will not interpret this matrix, I leave it to you. But our own saint one, Tirupati in Tamil Nadu, long back, about 1500 years ago, he has said, it's fine, our knowledge is fine, but we need actually a leader in whose head the knowledge actually is residing and who can practically apply that knowledge to lead his team to victory in war. So he says, mind of the commander is key to winning. So that's a very important point to note. Now I said this knowledge is important, and then mind of the commander is important, going by whatever our pundits have said from the past. One of the things that comes to our mind when we talk about knowledge and information is the so-called common operating picture. As we can see, it gives you some rough idea of what are the basic details that the commander of forces must have. So basically he has to have complete information about his own assets and their actual distribution, and what assets he has in stock and what assets he can quickly create. All this he has to have. And the second thing is that this information must be shared. It should be commonly available to all the force units, right down to the last soldier, to the extent that he needs to know. That is why it is called a common operating picture. But at the same time, this picture should also include what our enemy has. That has to be also identified and then integrated into this common operating picture. Now together, this information has to be also continuously updated. In this context, in fact, I remember some very legendary observation of a famous scientist by name Laplace. Some of you might have heard about him. He lived in the glory days of Newtonian dynamics, and he was in the court of Napoleon. And Napoleon, as you know, was a great general, war general. So he proudly said, this Laplace, when Napoleon asked, what is your outlook, how do you support warfare from your angle? He said at that time, well, if I know the positions and momentum of all the particles on earth, in the universe, using my own laws and Newton's laws, I can predict any future time very accurately. The only requirement is that I should know the positions and momentum very accurately. Of course, that is where the catch is, but it is not possible for anyone to know. Perhaps with some massive supercomputers it might be possible, but then that's what he said. If I know all the positions and momenta of all particles in the universe, then I can predict any future state without any problem, with full accuracy. Because the laws were clearly known. What were not known were actually the input data. The laws were knowledge, the input data in fact were required to use that knowledge to project into future. But a similar thing can be applied if you know your own assets and enemy's assets. Here we are not talking about particles, we are talking about actually macroscopic defense objects and their basic mechanics and their dynamic behavior, etc., and the nature of usage, exactly how they will be fielded. So if this knowledge is available with a much smaller number of entities to be handled, certainly a simulation system should be able to project this entire common operating picture into its future. So this possibility actually, in my opinion, theoretically at least exists. So we go to Now models, when we talk about common operating picture, there are two sides. One is yourself, the blue force, the other side is the red force, your adversary. So you have to have some models. Games are of course natural models. You also know about chess as a game. Chess gives you the fundamentals of how you can fight against an opponent. In fact, if we study chess very carefully, you will find correspondence between the elements in the world of chess and the elements in the actual battlefield. It starts with the theater of war, which is nothing but the board, etc. The tactics and strategies are what are the moves. But the so-called net-centric system, what it could be? Obviously, it has to be the player's mind. So we are gradually, getting into that complex object, which we should understand before we can, in fact, implement out of that mind a network-centric defense system or operation system. But of course, there is one famous observation of von Neumann. He said, chess actually is not a game, it is actually a computation. He said if he knows any particular position for winning, the next positions and all can be very accurately calculated based on some objective function. Those of you who are computer scientists here would understand what I am saying. But even though he said that, as far as humans are concerned, chess is still actually a game. When we talk about this common operating picture, first you will have to get the sensory data, you will have to fuse them, and then after fusing, getting the operational picture, you will have to also do what is called the situation assessment, and after that assessment, you have to do resource planning, and then tasking, and while you are doing all this using computers, obviously, you will have to take care of cyber security. So these are very important objectives or concerns when you are trying to develop a network-centric system. Conventional understanding of a network-centric system starts with the sensor grid, and then you have the communication grid, and you have the information grid where the decision making happens, and then the weapon grid. So normally one talks about these four grids, and you also have what is called this OODA loop. That is O for observe, O for orient, D for decide, and A for act. OODA loop as it is called. This also was created by the same kernel as part of his approach of net-centric defense. So we will have to in fact pay attention to all that. But when this gentleman Boyd was talking about net-centric system, what did he have in mind? What was he intuiting? Network actually is a distributed entity, whereas center is a point. So how can you say you are developing a network-centric system? Actually, I think though it is a geometric contradiction, there is a simple resolution. If we talk about human mind, it's basically a network of neurons. Neurons are all interconnected, as we will shortly see in some other slides. And basically, the brain is a gigantic graph, network in fact. But then we don't see the individual elements. When we use the brain, it actually behaves like a super organism. So that is how the resolution happens. There is no real contradiction. Yes, it is a network, but it behaves as a super organism. Now, that means the whole actually has to be greater than the sum of the parts. Because when we put lots of small pieces together, you get a whole organism. But the organism as such actually is more than the sum of the parts. So exactly how much more is the sum of the parts? That question has been answered by one famous strategist by name Metcalfe. He says, in the case of this kind of networked entities, the power of such an entity grows quadratically. That is, if you take a simple sum of n entities, the power is n. But if you actually network all of them, then the power is n square. So there's a whole world of difference between power n and power n square. So this is a very important message for designers of network-centric defense system. So when you network and when entities trust each other, then together their power actually grows quadratic. And this is a very important insight to keep in mind. So when you look at all this, now we come to the point whether all this can be handled successfully in individual commander's mind. So there is in fact some meeting, as the cartoon says here, There are so many branches, so many stages, and obviously, it cannot be done in the mind. We will have to go to the computers. Today's computers would be able to do it, perhaps not. So we will have to see how, in fact, we have to think of some supercomputers. Life technology has been imitating life. This is an example of a sonar. We have created the aircrafts. So how much time do I take? So I'm in fact now basically coming to the main point of my talk. So the basic idea is, can brain be the inspiration for a network-centric system? So there are many observations about brain. There are a couple of very interesting observations. Without qualification, it's the most highly and most intricately organized matter in the universe. And there are some macroscopic points, like it weighs about 1400 grams and 10,000 genes, in fact, determine its organizations, etc. And this is a very interesting slide. You have to look at this. So it shows, in fact, the relative sizes of the brain, from the animal brain as it is evolved to the human level. From this picture, you can get a rough idea that over 200 million years, the shark brain, or maybe the fish brain, has evolved to the current brain, and you can say linearly it has increased by about a factor of 8. So it has become 8 cube times from the original size. Of course, you may say bigger animals have bigger brains, etc. But taking that into account also, one can say the human brain actually is the biggest brain of all the living creatures in terms of the brain size to the body size ratio. But as I said, basically the sizes increase linearly by a factor of 8. Now this has happened over a period of 200 million years. So we are not going to wait for the next super brain to be created by biological evolution. And we will have to take this job in our hand, and we will have to see whether using computing, communications, and storage technologies, whether we can actually achieve this outside the domain of biology. So I was talking about industrial age. One important marker of the industrial age is that there was force multiplication. Things which we were doing, we could do using machines much more effectively. There were machines which could lift things much more powerfully, much more quickly, and there were machines which could in fact transport things much more powerfully than us. So basically we could amplify our muscles. That was what primarily happened during industrial age. Now, if you are talking about information age, you will have to ask the question, are we having systems that actually have amplified our mind? I would say the jury is out. You have to still see how effectively whatever the human mind is doing can be done by an independent computer, however big it is, however huge storage capacity is. That is a challenge. In my opinion, we are at the beginning of the information age, but we have still a long way to go. Now, I'll skip some of these slides for lack of time. Well, we'll have to in fact start understanding how human memory works. That is the first step. And then how language works, language making in our mind. Briefly, in fact, I would like to mention these two things to you. In the 1950s, 40s, 50s, there was this debate between behaviorism and innatism. Behaviorism projected that the human mind actually is a black box, and it takes input and then converts that into output. Of course, this black box is decided based on learning or training. Once you train yourself, you acquire a certain black box to deal with input corresponding to that black box, and you produce output. But then came along this Chomsky, and he said, no, brain is more complex than that. It is just not that we have black boxes, but we also have space to store data, and the function f that transforms input to output is not just fixed, but it is actually something that varies depending on the immediate past. That is, the immediate past data also can decide how in fact the transformation really will give the final result. So his idea prevailed, and finally we have a decent understanding of how language processing happens in the mind. There is one example given here. So when we are talking about this net-centric system inspired by brain, the first important thing we'll have to do is we should be able to process text data as intelligently as human brain does. So there are a list of things here in the red box. All these things we should be able to do. Now this we can do either using neurons and interconnections or using conventional methods which are actually available in computers today, but we'll have to scale them up. This is another example of a grammar which could be the basis. But I come to the final important faculty. Even today it's a far cry for computers to see any image and any video and then give you a complete list of identities of the objects and maybe even tell you what are the activities happening in a given video. So this is where currently in fact we have to focus. There are some efforts in fact to recognize objects, but I would say still we are scratching the surface. I propose that basically you will have to finalize a representation which is based on maybe a graph, maybe some kind of a network again, because the brain itself is a network, as I said. So any given scene first should be converted into edges as you see here, and also maybe converted into points or vertices. There are methods to do these things. And then you come to final graph representation. You just check all the edges and see what corners or what points are voting for them, because you have got independently points also. Similarly, you have points and then you see which points are voted by which set of edges. So in an iterative manner, you can come to a final representation, graph representation of a given scene. So if you have a huge database of graphical representations of all real world objects, then by correlating that database with your graphical representation of a given scene, you should be able to identify all the objects. That is what is basically required for creating the common operating picture. Now, this actually gives you a complete list of building blocks required. I mentioned 2 of them. There are many other things like common sense reasoning, data mining, geographical information system, and information validation. So you cannot just accept whatever information comes to you as final. You will have to see how you have to validate them. That's where common sense reasoning will be useful. Now, we have to put all these pieces together, and as you can see here, we have force advantage. We have machines, which can do what we want them to do by controlling them. But we will have to also get what is called information advantage over our adversaries. We have to have better information, more accurate information than them. But we also have to have better cognition of what we have. That is basically the cognitive advantage that this particular diagram talks about. So if we put all these things together, then we might have what is called the network-centric defense system that can help us prevail over our adversaries. But this calls for what is meant by developing the machine brain. So whenever any complex technology like machine brain or anything is proposed, there will be always some reluctance. So we will have to overcome this. And there will be a lot of stakeholders who may not be able to appreciate, and we will have to patiently explain to them and then take our technology age to the next stage, which is information age. With this, I thank you once again for your patient listening, and I thank the chair and co-chair for this valuable opportunity. Thank you very much.